correct?
Yeah.
F prime of 7 is 0.
Yeah, correct.
F double prime of 3 is 0. F of 3 is 2.
Correct.
F double prime of negative 1
Yeah.
is positive.
Yes.
F of negative 1 is negative 5.
Yes.
F of 7 is 0.
Oh, I missed. F of 7 is 10. Sorry.
That's okay. No worries.
And then, yeah, F of 7 is 10, and then I have the F prime of 7 is 0. Unless you already have that.
F double prime of 7 is
yeah,
less.
you already have that one.
F double prime of 7 is less than
no,
0.
Is less than 0, correct.
Double prime.
Yes.
Perfect. Is there anything else?
Yes.
So we have 8 conditions.
No, that's it.
So we have 8 conditions, correct?
Yes.
Okay, perfect. So remember, this is a typical situation in which I strongly recommend use the table. Without using the table, it's almost impossible to come up with an example of a graph or an example of a function. So one by one, we'll put them in here. So first of all, f of 7 is 10. So 7, f of 7 is 10. Done. F of 3 is 2. Done. The first derivative at negative 1 is 0. Done. The first derivative 7 is 0. Done. F of negative 1 is negative 5. Done. Now, the second derivative at 7 is negative. Done. The second derivative at 3 is 0. Done. And the second derivative, negative 1, is positive. Done. I no longer need that. So now I'm going to analyze a little bit and see what's given to us. Obviously, because the second derivative here holds water, here does not, this must be an inflection point. This must be an IP. When the second derivative is 0 or undefined, but in this case it's 0, and it changes sign, that point is an inflection point. Now, let's analyze what these are. When the first derivative is 0, these are critical numbers. We have the points, negative 1, negative 5, 7, 10. The question is, what type of point is this? What type of point is negative 1, negative 5?
A relative min.
Exactly. It cannot be otherwise. You wouldn't be able to open up if it were anything else. So this is indeed a relative min. Now let's analyze this one. What type of point is, but only because the derivative is 0. Okay? So which means that they are critical number. What numbers? What type of critical number is 7?
A relative max.
Exactly. Only now I know how to graph an example. So the first point is negative 1, negative 5. The next point is 3, 2. And the last point is 7, 10. 3, 4, 5, 6, 7, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is a relative minimum, and this is an inflection point. And this is a relative max. Done. I like to call these problems, if you remember, gibberish. What is this? This is this bunch of stuff. I can't look at this and make sense of it. But look what happens now. Once I organize all the information in a table, now I know exactly what it tells me. Because otherwise, it doesn't mean anything. Very good problem. Thank you for bringing that. Any questions? So once we put everything in the table, it enlightened us. It told us exactly what we needed to do.
Oh, let me ask this. So at the where we wrote 2, why did we write 0 under it? Like F double prime. Oh, because F double prime of 3 is 0. Oh, never mind, I got it. I answered my own question.
Good. I love it when that happens. Good. Next question.
Yeah.
Next topic. Anything else? Anything else? Other topics? Other questions? Is there anything else that we would like to review? This is our last class. So what else would we like to go over? I thought somebody else said one other topic, but I don't remember what was the topic. Mike, did you have something? Did you have something else? Did you say something else?
I thought it was at least squares technique and then integral substitution.
So the least squares technique is this one that we just discussed. This is the least squares technique. This is it. And what was the other one?
Integral substitution.
Oh, yeah, of course. That is in 4.5. Any problem from pages 434, 435? Good, I'm ready. Anything? Anything you like to pick? Definite, indefinite, anything you want. Ready? Anything? Which one?
Wait a minute, I'm thinking on mine.
I couldn't hear you.
Okay, let's do 60.
60, 60. Okay, very good. So the integral from 0 to 2 from 3x squared dx over 1 plus x cubed to the 5th power. Perfect. Very good, perfect pick. Okay, so obviously we have to use a substitution. Can anyone suggest a substitution here? What do you think? What would you try?
1 plus, oh, wait, I can't see that. It's 1 plus x to the third.
Exactly. As long as we can find du, what will du be? We have to find the differential of this function.
3x squared.
Very good. Yes. And we are very lucky. Very lucky. So do not copy the limits of integration. So all we have now is u to negative 5 du. It's du over u to the fifth. When x is 0, what is the lower limit for u? When x is 0, the lower limit for u is?
1.
Perfect. When x is 2, what is the upper limit for u? When x is 2.
Nine.
Very good, awesome. So therefore, I have u to negative 4 over negative 4. We add 1 to the power and we divide by exactly the same thing from 1 to 9. Please leave the negative 1/4 in front. Change this into 1 over u to the fourth. And then plug in 9. So negative 1/4. Plug in 9. 1 over 9 to the fourth. Minus when you plug in 1. And you can leave it alone. Very good pick.
There was a question like this on the exam, but remember that I think it was like 9xd, and it had like bottom, it would have said like 1 plus 3x to the third. Would it have been correct to now find the derivative? So that would make it, the bottom was 3x to the third. That would make it 9x to the second, and then multiply the top value by 3.
Yes, but yes, I think I understand what you're asking, but I think you should dictate the new problem or the variation you try to work on so everyone understands the steps. So if you have the problem, please give it to me. I think I am on page 7. Yes, I'm on 7. So just change the problem so we can look at it. What was the change you wanted to make?
Okay, I can make one.
Oh yeah,
So
yeah.
it would be the integral of 9x squared of dx, alright, over, let's say, 1 plus 3x to the third.
Good. So in this case, we still have 1 plus 3x to the third. And we still have du, which will be, in this case, 9x squared dx. So you still have here du over u. But this one, because it has power 1 in the denominator, this will be the natural log of the absolute value of u plus a constant c. And you have to go back and plug it in. So you have natural log of the absolute value of 1 plus 3x to the third plus a constant c. If we are to consider indefinite integral. That's okay. I mean, you can make up if you want to make up another integral, please do.
Okay, so what if it was like this, but instead of 3x to the third, if it was 4x to the third?
4x, not at the top. So what do you have at the top then?
So, okay, at the top, let's use it. So 4x squared of dx.
Not of, multiplied. 4x squared dx, not 4x squared of dx. It's a product. 4x squared
Multiply.
dx, yes, over. Well, you don't have to say that. You just say 4x squared dx. Over.
Okay, 4x squared dx.
Perfect.
Over, let's say 3 plus 3. No, sorry. Let's say 5x to the third. Okay, no, that works. I want to see, or 3x to the third. Let me try that.
It doesn't matter. It's the same thing. So you have u equals 3 plus 5x cubed, and you have du equals 15x squared dx. So you have the x squared. These are the most important ones. You don't have the 15, so you'll multiply by 15 and divide by 15. You will move 4 outside, so you have 4 over 15. Then you have 15x squared dx will be du over u. Same thing. So then you have 4 over 15, natural log of the absolute value of 3 plus 5x cubed plus a constant c. This constant here doesn't matter. You can always make up what you need, as long as it's just a number.
Okay, no, this helped. What I did was that I took. Okay, so what I did was I took that number 3 because we multiplied 3 times 5. I did 3 times, the top value. So I did 3 times 4, for example, and then used that as my value.
But 3 times 4 is not 15, so you cannot do that.
Correct. Yeah, that's what I'm saying. I made a mistake of multiplying.
That's okay. That's okay. Now you know. So another way would be to solve for x squared dx. X squared dx is d over 15. du over 15. It doesn't matter.
Okay.
It doesn't matter how you do it. When it comes to a factor, I prefer multiply and divide. It's much easier. But you can say no. You can solve for x squared dx. So when you solve for x squared dx, you have du over 15. And this is what I have. Du over 15. The 4 is outside. I have du over 15. 4 is out. And the denominator is u. It's the same thing. It's just that I think that when it comes to just one factor, it's much easier to multiply and divide. Because this is 1. I'm not changing anything.
Yeah.
But it's up to you. Everybody, you're feel free to develop your own style. Now, if it's something more complicated, it's not just a factor, then it's a different story. But if it's just one factor and everything else is there, you choose.